Good morning, students. It is 11th Physics, chapter number 4, lecture number 4. In this lecture, we will discuss about the projectile motion. But before that, I will repeat one topic because that topic will be used in this lecture or in this topic. Suppose it is any vector A. It is representing its length, or you can say its magnitude as well as direction. We want to resolve this vector along two mutual perpendicular components. That is, we will resolve it along two mutually perpendicular, that is, those two directions will be perpendicular, and either we take the single vector or those two vectors along given those two directions, effect remains same. So what is the procedure? Suppose we want to resolve along one direction which is given, second will be perpendicular to first. So draw a perpendicular on this line. This angle is theta. From the end of this vector, draw perpendicular on this line and similarly on this line. So it will be rectangle. Suppose I say it is P, it is Q, it is R and it is S. So P, Q, R, S is a rectangle. According to parallelogram law of vectors, if two vectors acting at a point can be represented in magnitude and direction by two sides of a parallelogram, then resultant will be given in magnitude and direction by the diagonal passing through that common point. So in this case, this is the diagonal and it is representing vector A. It means PQ and PS will be the two vectors and their resultant will be given by PR. Or you can say PR will be equivalent to vector PQ plus vector PS. So we will find out what is the magnitude of PQ and what is the magnitude of PS. In triangle PQR, it is a right angle triangle. This angle is 90 degree. So QR, that is height upon hypotenuse PR, will be sin theta. It means QR will be equal to PR sin theta. PR is A, so it will be A sin theta. So along the given angle, the angle of theta was given, so along the given angle, this is PQ and perpendicular to first is QR or PS. So along perpendicular it will be A sin theta. This is along the angle, it is perpendicular to first. So perpendicular to first will be A sin theta. Now we will find out what is PQ. Now PQ upon PR, that is base upon hypotenuse, that will be cos theta. So PQ will be equal to PR cos theta and PR is A, so it will be A cos theta. So along this direction it will be A cos theta. So either we take this vector PR which was equal to A or two vectors A cos theta along this direction and A sin theta perpendicular to first. Effect will remain same. So we can resolve this vector along these two mutual perpendicular directions, either these two vectors or a single vector. Effect will be same. So that was about the resolving of vectors. Now we will discuss projectile motion, because in projectile motion resolving of vectors was required, so I explained that part again. I repeated that part. Now next is projectile motion. What is projectile motion? Suppose it is any object, this is any object. If I throw it like this, so it is following this trajectory. It was thrown, only once force was applied, it was making some angle with the horizontal, and after that it was just falling under the effect of gravity. This type of motion is called projectile motion. Initially object was thrown making some angle with the horizontal, and after that no force was applied. After that it was falling only under the effect of gravity. That is called projectile motion. So now I am representing, suppose this is our y-axis, it is x-axis, and object was thrown from this point making an angle theta with this horizontal. It was thrown in this direction with initial velocity u along this direction, and this angle is theta. It was thrown like this. So what will happen? It will follow this trajectory. It will follow this trajectory. It will gain height at this point, height will be maximum. After that this height will start decreasing and it will strike here. Now first of all we want to find out what will be equation for this motion. In how much time it will reach from this point to this point, that is time of flight. What will be the maximum height of this projectile? And what will be that horizontal distance? That horizontal distance is called range of the projectile. So what will be range of the projectile? What will be time of flight of the projectile? And what will be the maximum height? And before that we will find out what will be equation of this trajectory. This velocity is u. So along the given angle we know component will be cos theta of that vector. So it will be u cos theta along this. Perpendicular to first, it will be u sin theta. It means either we take u in that direction, in the given direction, or two vectors u sin theta and u cos theta along y-axis and x-axis, effect will remain same. Suppose I take any point on this, and suppose coordinates at this point are x and y. It means this horizontal distance traveled is x and this vertical distance, that height gained, is y. X is the distance traveled along the x-axis, y is the distance traveled along the y-axis. Suppose time is a t. A time t. What will be that distance? Along x-axis there is no opposing force. So this distance x will be horizontal component u cos theta multiplied by time. Velocity is constant, so that velocity multiplied by time, that will be distance traveled. Or from this equation you can find out what will be t. T will be x upon u cos theta. Now we will find out what will be y, what will be that height. Initial velocity along this component is u sin theta. So initial velocity is u sin theta. Distance traveled is y. So we will apply the equation s is equal to ut plus half at square. Our equation will be s for y component or for y direction. we will apply equation S is equal to ut plus half at square. What is u? Initial velocity along y-axis, it was u sin theta. So it is u sin theta into t. It is moving in upward direction, g is acting in downward direction, so that sign will become negative. So minus half gt square. So u sin theta into t minus half gt square. Now we will substitute the value of time in this equation from our first equation. That was our first equation. So from this equation we will substitute the value of time along y-axis. That distance was y, so y will be u sin theta into time, which is x by u cos theta. So x upon u cos theta minus half z t square. T square means x square upon u square cos square theta. That is y. This u will be cancelled, and sin theta by cos theta is tangent theta. So it will be x tangent theta minus half z x square upon u square cos square theta. That will be the equation of the projectile. Actually, it is equation of parabola. Non-medical students will study later. So that path will be parabolic, and equation will be given by u tangent theta minus half z x square upon u square cos square theta. So that will be equation. Now this equation contains the entire information about this projectile motion. Suppose I say y is equal to under root 3x minus 2x square. Suppose it is equation of the projectile. So this equation has complete information about this projectile motion. Compare this equation with the standard. X tangent theta under root 3x. So what will be tangent theta? Tangent theta is under root 3. It means we know what will be angle theta. It means we know the angle of projection. And coefficient, the sign is negative, that is also negative. It is x square, it is x square. What is coefficient of x square? Coefficient of x square is z upon 2 u square cos square theta, and it is equal to 2. Compare these two. Now we know the value of theta. We know value of z, so we can find out what will be u. From this equation, we can find out what will be u. That is, we can find out what will be u and what will be theta. That is, what will be direction of projection, that is angle of projection, and what will be initial velocity along that direction. And if we know these two parameters or these two physical quantities, then we can calculate the remaining parameters or remaining physical quantities of this equation and this motion. So that was all about the equation of motion. Now we will calculate what is the height, what is the horizontal range, and what is time of flight of this projectile. First I am calculating time of flight. Time of flight. What will be time of flight of this projectile? If I take vertical component, this vertical component is decreasing. Actually, at any point, horizontal component, this is the horizontal component, this is the vertical component, and it is its resultant. At highest point, vertical component will become 0. So only horizontal component. At this point, this is the horizontal component, now it will start falling downward. This is the resultant. So it will take some time in acquiring the maximum height, and after that it will start falling. So we will calculate time interval or time period in which it will reach from this point to this height, maximum height. In how much time it will travel that distance? Total time of flight will be twice of that. It will go up to maximum height, then after that it will start falling. So total distance, total time will be twice of that time. So we will find out in how much time it will attain maximum height, and time of flight will be twice of that. I am taking velocity along y-axis. Initial velocity along y-axis, uy, it is u sine theta. At highest point, final velocity vy, that will be 0, y component will be 0. Acceleration is minus g. My aim is to calculate time, so you can apply the equation v is equal to u plus at. Vy is equal to uy minus gt in this case. Vy 0, uy u sine theta minus gt. So t will be u sine theta upon g. That will be time taken in attaining the maximum height. So what will be total time? Time of flight, it is represented by capital T, it will be equal to twice of the small t. So it will be 2u sine theta upon g. That will be time of flight. That is, from this point to this point, it will reach from this point to this point. In this process, it will take this much time. That will be time of flight. Now we will find out what will be the maximum height. What is that maximum height? Suppose that maximum height is h. Again, we will take motion along the y-axis. Initial velocity uy u sine theta. At highest point, final velocity 0. Acceleration due to gravity minus g. Our aim is to calculate maximum height. So v square minus u square is equal to 2gh. We will apply that formula. V square minus u square is equal to 2gh. Final velocity is 0, so this term will be 0 minus initial velocity u square sine square theta will be equal to minus 2gh, because g is acting in downward direction and particle was moving in upward direction, so g will be taken as a negative because it is acting against the motion of the particle. This negative sign will be cancelled, so h will be u square sine square theta upon 2g. That will be maximum height, or you can say height of this projectile. Now we will find out what is that horizontal distance from this point to this point. That is called range. So now we will calculate range of the projectile. Now how to calculate range? Component along this direction is u cos theta, and there is no opposing force. We are neglecting air resistance. There is no opposing force along this direction. So that component will remain u cos theta throughout its motion. And we know the time of flight. So if I multiply that horizontal component with the time of flight, then I will get the total distance. Time of flight was 2u sine theta by z. Time of flight 2u sine theta upon g. So horizontal range R, that will be equal to u cos theta into time, which is 2u sine theta upon g. This is velocity, it is constant. This is the time, so velocity, constant velocity into time, that will be distance traveled. U into u square in, now I am writing this 2 sine theta cos theta upon c. 2 sine theta cos theta is equal to sine 2 theta. It is trigonometrical identity. So it will become u square sine 2 theta upon z. So u square sine 2 theta upon z will be horizontal range. Now we will find out what will be the maximum horizontal range, or you can say under which condition horizontal distance traveled will be maximum. This distance will be maximum if this value has, this sine 2 theta has maximum value. And maximum possible value of sine theta is 1. So you can say maximum value of this sine 2 theta should be 1. If it will be 1, then R maximum will be u square by z. So for R maximum, R will be maximum if sine 2 theta is 1 or 2 theta is 90 degree. We know sine 90 is 1. So 2 theta should be 90 degree or theta should be 45 degree. So if angle of projection will be 45 degree, then that particle will travel maximum horizontal distance. So if you want to throw any object up to maximum horizontal distance, then you will have to throw that object with an angle of 45 degree with the horizontal. And what will be maximum value of range? R maximum will be, this term will become 1, it will be u square by z. That will be maximum horizontal range. So we calculated time of flight, horizontal range, maximum height, and we derived equation of motion, equation of this projectile motion as well. Now we will take one case. If I change this angle theta from theta to 90 minus theta, then what will happen? Suppose angle of projection is 30 in first case, and in second case I am taking it to 90 minus theta, that is 90 minus 30, that is 60. So is there any relation between these two? Suppose angle theta prime is 90 minus theta. For angle theta, horizontal range was given by this u square sine 2 theta upon g. Now we are changing this angle theta to theta prime, which is 90 minus theta. So what will be R prime? R prime will be u square sine 2 theta prime, and theta prime is 90 minus theta upon g. U square sine 180 minus 2 theta upon g. Sine 180 minus 2 theta will be equal to sine 2 theta. So it will be u square sine 2 theta upon g. R was u square sine 2 theta by z. R prime is also u square sine 2 theta by z. So whether angle of projection is theta or 90 minus theta, in both the cases horizontal range will be same. So horizontal range will be same in both the cases, whether angle is theta or 90 minus theta. So prepare these topics. In the next lecture we will discuss it further. Thank you.